In this video, I will explain you about size of the nucleus. We have nucleus at the center of an atom and having orbits around it. So I am going to talk about the size or the radius of nucleus. Okay, now radius of nucleus is directly proportional to atomic mass number. It's not atomic mass number power 1 by 3, or I can say cube root of atomic mass number. So if atomic mass number is 8, then that would be R is directly proportional to cube root of this would be 2. Now if atomic mass number is 27, then that would be cube root of 27, which is 3. Okay, anyway, this is a very important relation. Now I would tell you how this equation has been derived. We know that density is equal to mass by volume, and volume is equal to density into density divided by volume is equal to mass divided by density. So I'll take volume here, we'll transfer density here. So mass by density is equal to volume. Okay, now if nucleus is a sphere, what would be the volume of the sphere? So nucleus is a sphere with a radius is equal to r. So we know the volume of sphere, which is 4 by 3 pi r cube. So this would be 4 by 3 pi r cube, where r is the radius of the particular the radius of the nucleus of the particular atom we are considering for this experiment. So this is equal to, now m is nothing but atomic mass, right? So we know m is directly proportional to mass number. So atomic mass of hydrogen is equal to 1. So 1 into some number is equal to the actual atomic mass, right? And atomic mass of helium is equal to 4. This is He2 4. So actually the mass would be 4 times a number. So I can say that mass is directly proportional to the mass number always. So I am going to take a value mass number or mass number multiplied by the constant. Okay, I am only going to take mass number multiplied by a constant. Okay, anyway, directly proportional to mass number divided by density. So density of the nucleus would be constant, right? So I can say that here r cube is equal to, I'll transfer everything the other side. So 4 into constant, 3 would come here, 3 constant divided by 8 into 4 pi. So r cube 3 into constant divided by 8 into 4 pi into a. So here the only variable we have is r and a. 3 into k divided by 8 into 4 pi. Yeah, correct. Okay, so all these are constant. So this constant I am going to represent as r0, and this is a. R cube is equal to r0. It's not an r0, it's a constant. Okay. Now take the cube root of this. So r is equal to cube root of constant, again would be a constant, that I am going to mark it as r0 into a power 1 by 3. I am taking cube root of everything. So r cube root is r itself, k cube root would be 0, r0. I can say cube root of 8 is 2. So 1 cube root of any constant would be a new constant, but I have r power 1 here. So I can say that both of these would be in the same dimension. Now I can't replace it as r0. Why? See, it is r power cube and r0 power 1. So if these are two same physical quantities, then it should carry the same power. Okay. See, m power 1, and if it is length this side, I can't equate with mass of an element or mass of substance with length of different substance, because mass is one physical quantity, length is different physical quantity. But I can equate mass of 5 oranges to mass of 2 apples. See here, comparison of mass. So comparison of mass with length is not possible. So all of them are in the same dimension. So the moment I have converting r cube into r, then k power 1 by 3, I can consider it as r0, so that both will have the same power. If it is making confusion, then leave this part. So this is not coming in your syllabus. Okay. Anyway, r is equal to r0 into a power 1 by 3, or I can say r is directly proportional to a power 1 by 3. See, r is directly proportional to a power 1 by 3. Experiment. So this would be constant of proportionality. This can be converted as equation by multiplying with a constant of proportionality r0. This would be the equation. Now r0 is 1.2 into 10 power minus 15 meters. I told you, right? Now both will come in the same physical quantities, because r is measured in meter, even r0 is measured in meters. Both are in the same dimensions. Okay. A has no dimension. Why? Because this is a number. But if you are taking atomic mass here, then this would be wrong, because atomic mass has got a unit which is kilogram. That is the total mass of an atom. Okay, but here in this case it is mass number, which is just the total of number of neutrons and number of protons. That would be a dimension less quantity, because that's a number. Okay, so r0 is this, and now you can get the radius of any element. For example, what is the radius of hydrogen? That would be r is equal to 1.2 into 10 power minus 15, that is r0, into what is mass number of hydrogen? 1. So 1 power 1 by 3, that is 1 itself. The value would be same. So this value is nothing but radius of hydrogen, radius of nucleus of hydrogen atom. Here I am only going to talk about size of the nucleus. Okay, and what would be the radius of nucleus of helium atom? That would be r is equal to r0, 1.2 into 10 power minus 15 meters into mass number is 4 power 1 by 3, cube root of 4. So this would be the size of the nucleus of helium atom. For carbon, we can use 6 here and get the value of radius of nucleus. Okay, and now density of the nucleus, for as a general information, you can just learn this: 2.3 into 10 power 17 kilogram per meter cube. So just consider a meter. So meter would be approximately this much. So a meter length and a meter width and meter height. If it is fully filled by nucleus, then the mass would be this much. How much it would be? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. I already have considered here. So this much kilogram in the meter cube box. This would be the weight of a box which is fully filled by nucleus. Okay, so this itself give us an idea that when we are filling a box with any material, the number of nuclei or size of the nucleus is very small. So let's say I have filled a bottle or a tank which is 1 meter cube, 1 meter length, 1 meter width and 1 meter height. If I am completely filling it by water, then if you are taking the all nucleus of hydrogen and oxygen atom, H2O is water, right? All the nucleus to one corner, that won't be even, the tip of the nib. That would be such a small size. So that gives a value that nucleus is a small thing and an atom is a very big thing. Size of a nucleus can be compared as size of football in a football stadium. The whole stadium represent an atom. Size of the football represent size of nucleus. Okay, so this is the case. And even when I am filling a tank of 1 meter cube, 1 meter length, 1 meter width, 1 meter height with water, then the total mass it carries is 1000 kilogram, because 10 power 3 is the density of water. At the same time, if it is fully filled with nucleus, then this would be the mass of the box. Okay, carrying nucleus in it. So nucleus is the heaviest element in an atom. Okay, thank you.